long. Can't get this anywhere else. This is Ro.Go's COVID-19 Classroom Prevention Plan, which will be taking place in room 233 at the illustrious Hendrick Hudson High School. In this presentation, you will learn 1. What the coronavirus is. 2. What the coronavirus does. 3. How the coronavirus spreads. And 4. What we will do to not be tagged by the coronavirus in class. Yes, we are playing a game of epidemiological tag with the coronavirus, and it is looking to tag us all the time. And the bummer is, if we are tagged, we may die. First, a primer on viruses. What is a virus?
Walter Reed discovered the first human virus in 1901. But what is a virus? Viruses are everywhere, from our surroundings to the very food we eat. We ingest, inhale, and take in millions of viruses every second. Pretty much all life on Earth has some kind of virus designed specifically to infect it, including bacteria and even other viruses. Viruses are tiny, very tiny. You cannot visibly see them. In fact, they are so small that if bacteria had eyes, even they wouldn't be able to see all of them. Most scientists accept that viruses are not living, but a complex collection of organic matter that is able to self-replicate. They mostly consist of a shell made of protein, which inside contains either DNA or RNA, with enzymes for replication and manipulation of their genetic materials. Are you still with me? Good. Let's look more closely. A virus is actually just a piece or strand of genetic information, usually DNA or RNA, which can be single or double-stranded. This is the virus's genome. It uses this with the help of various molecular machines to replicate itself. However, it cannot do this alone. It must infect some kind of cell. Cells are the smallest unit of life. They manufacture proteins, replicate DNA, and store resources. This makes them perfect hosts for viruses. Armed with its genetic material, viruses are able to infect healthy cells and convert them into mindless virus-producing robots. The virus uses its outer protein coat, covered in small molecular receptors, to bind and join to the membrane of a cell. This is essential, as it is what determines which cells a virus is able to infect. Once joined, the virus uses several complicated biological pathways in order to force the cell to either accept its genetic material or take in the entire virus itself. Once in the cell, the virus will then begin to use its molecular arsenal to hijack the cell's protein manufacturing systems and DNA replication mechanism. After the virus has integrated itself into the cell's own DNA, the cell will then replicate its DNA and use it to manufacture proteins. Without the cell even knowing, it produces viral protein shells, filling them with virus DNA, effectively making copies of the virus and assembling them. The virus-making machine begins to take over more and more of the cell's protein manufacturing ribosomes, churning out thousands of new viruses which quickly fill the cell. These viruses then cause tension within the cell and by several different means burst from the cell with the intention of infecting new hosts for the same purpose. Seems like relentless biological vandalism to me. Viruses are not all bad though. Some are being used to help strengthen disease resistance in crops, whilst others, such as HIV, are being used in curing certain types of cancers. But what is the most remarkable of all is that many scientists believe some viruses that infected bacteria billions of years ago helped form the first cell nucleus. If this is true, then all complex cellular life on Earth descended from a single virus and his rubbish attempt at trying to infect a bacterium. Now that is remarkable.
All right. So, from that little video, what do we know? Well, first, viruses are microscopic parasites that are like zombies. They're non-living, but active. They can only survive and thrive in a host, and in this case, the host is a human. They make copies of themselves inside of us. Now, the parts of the human body that are the main hosts for this coronavirus we're talking about are three vital organs: the heart, the lungs, and the brain. So, ladies and gentlemen, what is this specific virus? Well, 1. It is a novel, which means new, and in this case, new to humans, coronavirus. And this particular coronavirus has spread from animals or jumped from animals to humans. 2. Its official scientific name is SARS-CoV-2. SARS-CoV-2 stands for Severe Acute Respiratory Syndrome Coronavirus 2. You're wondering where the 2 comes from. It's because in 2003, a similar virus had an outbreak in 2003, but did not reach to pandemic levels. This virus, however, has caused a worldwide pandemic. 3. All right. The spike in the picture, I'm going to put my pointer on here, follow along, is the corona, which means crown. So it's crown virus. You see the spike here, known as a crown. And from the video, you notice this is the crown that attaches itself to our cells. All right, ladies and gentlemen, time to get serious. What exactly does this virus do? 1. First, it attaches itself using its spike to a host, a cell in our organs, and starts to replicate, which means it makes copies of itself. You saw that in the video. 2. These viruses then start to wreak havoc on the body. The virus gives you the disease known as COVID-19. So the virus is a coronavirus that has an official name, SARS-CoV-2. Once you are infected by this coronavirus, you have the disease COVID-19. 3. When this happens, the body's immune system is engaged and tries to fight the virus. So you get the virus and your immune system starts to work to try to stop the virus. This is where we have varying degrees of efficiency regarding our own immune responses, because number 4 is going to play the most important role in you paying attention here. Depending on the person's immune system and overall health, the virus inflicts varying degrees of damage on the person's organs. Some are fine, some die. People of all age groups have been affected negatively by SARS-CoV-2, from infants to toddlers to teenagers to 20-year-olds and 30-year-olds. People in all age groups have died. Now, 80% of those who have died in the United States of America are over 65 years of age. However, if you do your math, that means 40,000 people in this country officially, which many say that number is low, officially have died of COVID-19 that were under 64 years of age. One of my students currently in my classes had a family friend who died who was in their 30s. All right, this is the really bad stuff. These are the effects of COVID-19 on the human body for those who get hit the worst, who, because their immune system couldn't handle it, because they had too much virus in their body for one reason or another. These are the 2 really bad things that can happen to you that oftentimes could lead to death. Okay. So on the upper right-hand corner, the worst thing is something that is known as ARDS. Now, there are varying degrees of this, and the one that COVID-19 causes is unique. It's called acute respiratory distress syndrome. What happens when you have this is fluid builds up in the tiny elastic air sacs called alveoli in your lungs. The fluid keeps your lungs from filling with enough air, which means less oxygen reaches your bloodstream. This deprives your organs of the oxygen they need to function. Many people describe this as you drowning in your own lungs, in fluid in your lungs actually drowning you. The second thing that can happen that is quite alarming is something called a cytokine storm. The second bullet here. It's also called hypercytokinemia, and it is a physiological reaction in humans and other animals which the innate immune system causes an uncontrolled and excessive release of pro-inflammatory signaling molecules called cytokines. If you're not a science nerd or into science, that sounds like jargon, or Ro.Go, a specialized language used only for science. Let me break this down for you. Okay, so a cytokine is it's a molecule, and your body sends them out to try to fight disease, to try to deal with inflammation when your body is out of whack. Now, normally, cytokines are part of the body's immune response to infection, so it's a good thing. However, what COVID-19 has done, unfortunately, is caused your body to send way too many of them, and your body and your immune system go into hyperdrive. Okay, so the final point here is, follow the pointer, their sudden release, if there's too many of these cytokines being thrown off, come in large quantities, and they can cause multi-system organ failure and death. Basically, your own immune system causes your organs to fail because they are just in hyperdrive and going wild. Okay, so I do not want to contract COVID-19, and you shouldn't either, because the unfortunate reality of this virus, even after 8 months of study and trying to understand it, the scientific community knows that there are still many unknowns regarding the virus. So, there are potential long-term effects of COVID-19. These are not guaranteed. These may not be right, but these are scientific possibilities that have been put on the table that I personally do not want to deal with. First thing is scarred lungs. So what we were talking about, it affects your lungs and it messes with your alveoli. So it can cause permanent breathing issues. If you can't breathe properly and you can't process oxygen properly, you will have many nasty effects to your physiology as you grow older. Fatigue, headaches, weakness, just overall not good. Ask anybody with asthma how bad it is to not be able to breathe properly. Second, this one really is the one that is, the second bullet here is something that is really, really damnable towards athletes. One thing that they have noticed is you can have a damaged or inflamed heart from COVID-19. You can develop something called myocarditis, and that is an inflammation of the heart muscle. And this can cause lasting scar tissue and damage to your heart, and the heart is the engine of your body. So that can cause shortness of breath, fatigue, and this is the one that scares athletes, permanently diminished physical strength. If your heart cannot pump blood at the rate in which it needs during strenuous activity, you can never rise to the highest level of athletic ability. It's that simple. Another really scary thing that has come up about COVID-19 is it causes brain damage. It can affect the brain. It can make its way into the brain, burrow in that little virus and start replicating in there, and it does bad things. It's causing strokes, seizures, and Guillain-Barré syndrome. I apologize to the French speakers here that I butchered that. And Guillain-Barré syndrome is a particularly nasty nervous system syndrome that causes intermittent paralysis. So literally your body locks up because of it. All of these things have been reported and documented in regards to lasting effects of COVID-19. And if you have these issues with your brain, and this information is from the Mayo Clinic website, a highly regarded healthcare apparatus out of Cleveland, doctors and epidemiologists and scientists are worried that you're going to have a higher risk of developing Parkinson's or Alzheimer's when you're older. Another thing that's really disturbing about contracting COVID-19 is that you may develop blood clotting and blood vessel problems. Now, if you have this issue, if your blood clot's too high, you are at a severely increased risk of stroke or heart attack. And the blood vessel issues, if they weaken, have shown to have deleterious, that means really negative effects on the kidney and liver. These are things that are serious. And finally, some people have actually been termed long-termers from the virus. They've been dealing with really negative aspects: fatigue, mood swings, depression, anxiety. These really nasty and insidious and long-lasting effects of the virus have come to bear for some people. So it really messes with your psyche to not be able to fully recover from a virus and a sickness. And this is happening with people in all age ranges. Okay, next video. Important, so you know. It's not a good virus. So, how does it spread? We're going to watch 10 minutes of this video. I found this dapper young gentleman, and there's some simulations in here that I believe are apropos and will give a greater understanding of the coronavirus. All right, here we go.
Welcome back to yet another coronavirus COVID-19 video. It's becoming clearer and clearer now that this coronavirus spreads not just through contact and respiratory droplets that fly through the air like ballistics, but also it's being transmitted through the airborne route, meaning through aerosol. So meaning the virus lingers in the air and then someone comes and inhales that virus into their lungs. Let's face it, there is a reason why hospitals with designated COVID areas require everyone to wear a N95 respirator mask as well as eye goggles. That's because we know that this virus has the potential for airborne transmission. Previously, the WHO said that this virus only spreads through contact and respiratory droplets and doesn't spread by the airborne route, unless it was related to aerosol generating procedures like with an intubation or bronchoscopy, or when someone is using a CPAP mask or a BiPAP mask. It actually wasn't until July 9th that they formally recognized that it can be transmitted indoors by means of aerosol, or at least they said that they can't rule out this possibility. They finally admitted this after hundreds of experts had called on them to do so. And look, it's not like the WHO hasn't made blunders before. On February 25th, I made a video saying that this is a pandemic and explaining why that is. But for today's video, I want to start out by saying yes, unfortunately, COVID-19 is now a pandemic, even though it's not official, but it wasn't officially declared a pandemic by the WHO until March 11th. I don't know why it took them so long. Then there was the whole blunder of them saying there isn't asymptomatic spread, which we already known that it does spread asymptomatically for like 2 months at that point. And then the next day, they actually self-corrected. So why until recently have they not acknowledged airborne transmission? Two main reasons. One, because there is still no definitive evidence that proves airborne transmission. Of course, it's always nice to be sure about something before making a public statement, but sometimes you have to take action and implement safety precautions without having definitive proof. The second main reason is that declaring airborne transmission has big implications. You already see how bad things are with masks and social distancing and the debate over reopening schools and such. Well, if this virus spreads by the aerosol route, before I get into that, let's actually start out by defining what airborne transmission really is, because most people don't actually know what it really means. Let's rewind to February 11th when I posted this video explaining airborne transmission. Then there's airborne precautions. Some lung infections and some throat infections spread when small viral or bacterial particles stay suspended in the air and can be inhaled by other people. The 2019 novel coronavirus is believed to fall into this category. This category also includes other viruses like the SARS virus, measles, chickenpox, and tuberculosis, which is actually a bacteria. And then this study came about, and I made a video about it on March 18th. And there's now a new non-peer-reviewed study that just came out by NIH that shows the virus remains in aerosol, meaning in the air, for up to 3 hours. Now, at this point, we don't know how much of a viral load in that aerosol you need to inhale in order to come down with the infection. So that is still an unknown at this point. So just because it remains aerosolized for up to 3 hours, that does not necessarily prove that it's an airborne transmission, but I would think that's the case. More studies are needed to prove this one way or another. But let's get more into the nitty-gritty of aerosol transmission. During normal breathing and speech, tiny particles are emitted mainly from the mouth. These particles can range in size, with the smallest being less than a micron and the biggest being over 500 microns in diameter. Now, to put some perspective on that, the average diameter of a human hair is about 80 microns. Typically, droplets that are less than 5 microns are considered small, and it's these small droplets that can be suspended in the air. Droplets that are over 100 microns are considered large, and droplets that are between 5 and 100 microns are intermediate. But the reality is it's a range of sizes, it's a continuum, it's a spectrum, from less than 1 micron to over 500 microns. And more particles are emitted when someone is breathing heavier, such as with exercise, or if someone is coughing or sneezing, or if someone is shouting or singing. Due to gravitational forces, particles that are bigger than 5 microns tend to settle, meaning fall down on surfaces such as the floor, and they fall fairly close to the source, typically within 6 feet. This is why the CDC recommends 6 feet for social distancing. But here's the thing. Sometimes these larger particles travel farther than that, especially if someone is breathing heavy, or shouting, or singing, or coughing or sneezing. Typically, they fly no further than 12 feet in these situations. But we're also spraying particles that are smaller than 5 microns. And this is why these tiny particles, they don't act like ballistics. They act more like a gas cloud, where they float in the air and travel up to 27 feet. The ones that are less than 1 micron evaporate within milliseconds of hitting the air, while the particles that are more than 100 microns can take up to a minute to evaporate. So what happens when the droplets that are less than 5 microns, what if they're spewed from someone who is infected with the virus, and all of a sudden, in mid-air, they evaporate? Well, they dry out, and you're left with a virus that is floating in the air. These are called droplet nuclei, aka aerosols. There are lots of factors that determine how long aerosols remain in the air, just like there are a lot of factors that determine how long a fart will stink up a room. It depends on the person who emitted the particles, how they emitted them, the temperature and humidity of the environment. Now let's take a look at what happens when someone sneezes. This was published in the JAMA article, and they took a super slow motion video of a healthy person sneezing. You can see the varying degrees of droplet sizes. The larger ones fall to the floor like ballistics, but the tiny ones remain airborne in this wet cloud, if you will. Not only does this wet cloud help keep the virus viable for a longer duration, but this cloud can travel about 23 to 27 feet depending on the conditions. Lack of airflow means that this cloud will persist longer, and when this moist cloud finally does dissipate, you're still going to have droplet nuclei that stay airborne for about 3 hours based on that NIH study. A lot depends on the airflow of that environment. This is the reason why scientists in China actually found the SARS coronavirus 2 viral particles in the ventilation systems of hospitals that had COVID patients in it. Now, proving that airborne transmission exists is actually harder than one may think. The best way to prove it from a scientific standpoint would be to line up a bunch of people in a room who have COVID, okay, and then you line up a bunch of other people who don't have COVID, keep them 20 feet apart from each other, and then let them stay there for several hours and see who gets COVID. Obviously, from an ethical standpoint, this is what we call up. But what we can do is look back at real life situations that sort of mimic this scenario. Like, for example, what happened in this Chinese restaurant. In this study, they reviewed video footage after they realized that 3 different parties ended up being positive for coronavirus. What they realized was that there was no evidence of direct or indirect contact between the 3 parties who ended up getting the virus. Their results effectively showed that the infection distribution was consistent with airborne transmission. And they even recreated this scenario using a warm tracer gas and computers to simulate the spread of exhaled droplets from the index person, meaning the person who was spreading it to other people. And when they did the simulation, they were able to recreate that scenario. And then there was this. In a semi-rural area in the state of Washington, 60 singers convened for choir practice. Mind you, this area of Washington was not a hotspot. They didn't have any known cases at the time in this area. All the singers were feeling fine, they were in good health that day, and supposedly no one was known to be coughing or sneezing. Hand sanitizers were provided. They took measures to socially distance, presumably 6 feet, and they avoided hugs and handshakes and proceeded to belt out the high notes. Now, on to the sad part. Within 3 weeks of this event, 45 out of the 60 were diagnosed with COVID, and 2 ended up dying. So what was the conclusion? It was that most likely this spread was due to aerosolization. And recently, 3 passengers on a Delta flight came down with the virus, although we don't know the details, and this doesn't necessarily prove or disprove airborne transmission. So at this point, we might not have 100% conclusive evidence that proves airborne transmission, but there are now several studies that strongly suggest that to be the case. It's just like in a murder trial, if you have enough circumstantial evidence, you can still paint enough of a picture to get a conviction without necessarily having a bloody fingerprint. Now, just because we know that this virus spreads through the airborne route, that's not to say it doesn't spread through contact and respiratory droplets, meaning bigger droplets that act like ballistics. It spreads by all 3 of these mechanisms. So hand washing is still important, as is not touching your face or mask with dirty hands, and maintaining 6 feet apart is a good thing, but it's not good enough for certain situations. Remember earlier how I said when someone sneezes, that moist cloud containing aerosols can travel up to 27 feet, and the virus can linger in the air for 3 hours? Well, what good is 6 feet going to do you in that situation? It's better than no distancing, but it's not good enough. Now, some rooms have adequate ventilation that supply clean outdoor air and minimizes recirculated air. The better the ventilation, the less likely the spread of aerosols. And even cracking open a window can make a huge difference, and having a fan blowing is a good thing too. And generally speaking, opening doors is a good thing.
Open it! Okay, open it!
Other measures can help too, like having an air purifier with high efficiency air filtration and germicidal UV lights. And by the way, if you're looking to...
All right, that gave a basic primer on airborne transmission of the virus. Now, just recently, the CDC agreed with this and then redacted their agreement of the fact that it is airborne, but there are multiple hundreds of scientific people in the scientific community that are in agreement that the virus is airborne. That means it doesn't just spread through droplets and through fomite, which is through a surface transmission. It's also in the air. So, what do we learn? How do you contract the virus? How do you actually get it? Viruses enter the body through mucous membranes, and you have mucous membranes in your mouth, your nose, and your eyes, and another part of your body that I didn't mention because at school, you better not get the virus that way. All right? So you get it through your mouth, your nose, or your eyes. This is how the virus gets into those mucous membranes. 1. Someone who is infected expels viral droplets that touch your mouth, nose, or eyes. Think being close to somebody talking without a mask. They don't have a mask, you don't have a mask, or you have a mask, but they're spitting into your eyes. 2. You touch a viral droplet somewhere and then touch your mouth, nose, or eyes with your dirty, virus-infested hands. So somebody's spreading the virus somewhere, it touches a surface, you touch it, and then you touch one of your mucous membranes. Boop. COVID. 3. You inhale enough virus in a room that is floating around to infect you. And this is the tricky part here. This is why I'm making this video, really. Think of being in a room with virus hanging in the air for too long. All right. This is what is known. 1. The virus spreads asymptomatically. This means that it can be spread by someone who has absolutely no signs of sickness. You feel fine, you look fine, you're moving fine, you have no aches and pains, but somehow you've been infected, and every exhalation of breath that you use, every time you talk, you could be expelling virus. You could be the vector for disease. You could be the super spreader. 2. The virus is airborne. Listen to me. This means that social distancing and masking are not the only measures that should be taken in mitigating. That means making less the spread indoors. Indoors. There's a reason that things are happening outdoors, because outdoors allows for airborne viruses to spread out. The outdoors does not contain virus. It cannot cloud up like you saw in the video. 3. Different actions involving the mouth and nose expel different levels of droplets and aerosols that carry the virus. We'll go over that a little bit more in a couple slides from now, but there's a reason why singing produces, if you have the virus and you're singing, you expel more virus in the air by singing or speaking loudly than by just breathing. 4, this is vital. Ventilation. Ventilation means bringing fresh air into a room is the third key component to stopping the spread of the virus. We're going to go over that later, but this is really the main focus of this presentation. And 5, washing your hands properly with soap and or using effective hand sanitizer will kill the virus. Originally, during this whole thing, there was this craze over disinfecting and cleaning and hygiene practices. That's still there. The school itself focuses on this issue. And staying clean is good, and also will stop other viruses from spreading, particularly noroviruses that cause diarrhea. But in this case, you should not be touching your mask or your face unless you have cleanly washed or disinfected hands. Really quickly, check out my pointer. This is a quick table that was drawn from a study done in 1945 about what different activities produce different levels of droplets and aerosols. Okay, so you saw that in the video. So a droplet is a larger floating droplet in the air that could be carrying the virus, and an aerosol is a small. It has far less fluid and can dry up and actually make the virus float in the air. All right, so normal breathing does not produce much. A single strong nasal exhalation produces far more, a few hundred droplets or aerosols for each expiration. Just breathe in, breathe out. The exhalation, a strong nasal exhalation, can spew hundreds of virus droplets in the air. Counting loudly or talking loudly can also create hundreds in the air. A single cough with your mouth open, like can have a few hundred, but boy, you get one of those heavy coughs where your mouth is initially closed. A few hundred to many thousand viral droplets. Okay? And here is the crazy one, the sneeze. Let me try a sneeze. A few 100,000 to a few million droplets in the air. So this is why, okay? This is why, this is what we will be doing. This is Ro.Go's personal prevention plan. This is how we will stop the spread in room 233. Number 1, windows and door will remain open. This will provide ventilation. Fresh, virus-free air from outside will dilute any viral particles in the room. It's why you need warm clothing when the weather gets cold. Closing the windows and doors will create an atmosphere for the virus to accumulate in the air. Opening windows and doors is a simple, effective strategy that has been proven over time to provide ventilation to indoor spaces. So I'm sorry. It's going to be mad brick when it gets cold, but we will deal with that. I would rather have fresh air coming in from the outside and be safer than to be nice and cozy for a day and then be miserable with COVID-19. 2, you will stay distanced from each other and me, particularly inside. Social distancing decreases the chance of droplets containing the virus reaching someone else. Okay, period. That's why it's been de rigueur since day one during this pandemic. 3, you will wear a mask in class. No exceptions. Mask breaks will be outside. We are not going to take our masks off and then allow aerosols and droplets to accumulate indoors. If you want a snack, it will be during a mask break, not during class. And I've told you before, it's going to be cold, so you'll be bundled up, but also there might be precipitation happening outside. So go ahead and pack an umbrella or a rain jacket. You never know. And 4, you will clean your hands frequently with soap. Soap kills the virus. And you will cough and or sneeze into your mask. You're not going to pull your mask down to sneeze. You're going to deal with that nastiness that comes out. And you will cover your face. You will cover your face with the crook of your elbow. So you're going to sneeze into your mask and you're going to dap at the same time. You're going to take your nose in your mouth and you're going to bring it to the crook of your elbow and sneeze or cough into there. That is going to keep those viral droplets and those aerosols contained. Okay, finally. Here is a couple of small or short videos from Holt Architects out of Ithaca, New York. I saw these videos and it was like, oh, okay, this is why you wear a mask. This is why I personally am really distraught over the politicization of mask wearing in this country. Wearing a mask is simply a patriotic and valorous activity. There is no problem with doing it. And, making yourself suffer a little is a good thing. It creates stronger character. All right. So here's a couple of videos that are going to show you the difference between wearing a mask and not wearing a mask in an indoor space.
A few weeks ago, we mentioned that here at Holt Architects, we were going to be completing a computational fluid dynamics study of our office here at 619 West State Street. And in just a moment, I'm going to share with you some of the first imagery from that model. ME Engineering out of Syracuse, New York has assisted us with building a virtual model of this office space you're looking at, our open studio. And in about a moment, we're going to simulate a person infected with COVID-19 sitting in this workstation right in this location and begin to see how infected droplets might move through the studio. We modeled a number of scenarios trying to decide how Holt Architects would return to the office. Staff wanted to know if they'd be allowed to remove their masks when seated at their workstations. And for that reason, our first model represents an unmasked person coughing 3 times in about a 10-minute period. You should note that anywhere from light blue to red represents the HID50, or human infectious dose for COVID-19, and red is 5 times the human infectious dose. Notice that a cloud carrying a dosage 5 times that HID50 is carried 30 feet across the studio, and a normal infectious dose can travel more than 50 feet indoors. Finally, notice that the cloud of virus never reaches the mechanical system where filters could be effective. The first model gave us absolute clarity when deciding that all of our staff would be required to wear masks at all times unless in a single occupancy space with the door closed. Our next step was to determine under what other terms would we occupy our office, even with a mask mandate. We'll show you in our next video why 6 feet of distance and a mask may not be enough when indoors. If you have any questions or would like to see more animations, please email me at sh@holt.com. Thank you and be safe.
Okay, now is the second video that shows how effective a mask can be to stop those viral aerosols and droplets from being emitted and basically allowing them to cascade and dance around the room.
Hi everyone. We're back again to share more of our computational fluid dynamics study with you. As you might recall in the last video, we shared how our model of an unmasked person coughing in the studio 4 times in a 10-minute period compelled us to have a 100% mask mandate in our office. That is, our staff would wear masks at all times in all office public areas and would only be able to remove masks in single occupancy rooms. So the next logical step was to model a masked infected person in our office to first determine if we had an issue, and then secondly, begin to consider architectural mitigations. In this second animation, we've modeled our infected individual coughing 4 times in the same 10-minute period. The first notable thing here is that compared to the last rendering, the red cloud, which is 5 times the human infectious dose, instead of being transported 30 feet across the studio, is almost completely contained to the immediate workstation. However, and surprisingly, the light blue to green cloud, which is between 100 and 300% of the human infectious dose, can still travel more than 20 feet, with some of the cloud traveling even 50 to 60 feet. The conclusion here is that if you're indoors for an extended period of time with someone who has contracted the coronavirus, 6 feet in a mask could be a false sense of security. The mask is extremely useful in containing a droplet cloud, but it's not 100% effective. Those leaked droplets, as we've illustrated, can travel at least 30 feet in a cloud. And yes, being exposed to that cloud for just a few seconds might be harmless, but in an office environment where you sit for hours, you could have a high likelihood of inhaling those droplets even while wearing a mask. There are ways of greatly reducing the risk of transmission, like more air changes, diluting the indoor air, compartmentalization of space, and even light sterilization. And in our next video, we will begin to discuss some of those ideas.
All right, ladies and gentlemen, some final thoughts. So you see the difference between wearing a mask and not wearing a mask, and there's a reason that you're going to be wearing a mask inside. That should be abundantly clear at this point. So, first bullet. These classroom rules and procedures are non-negotiable. You will follow them, as will I. And the second one, and this is the reason why I have come up with these classroom rules and procedures. I have a responsibility to take care of you the best way I can when you are in my class, in all ways, shapes, and forms. I take this seriously. Now, if I did not do everything I could to keep us as safe as possible, then I could not live with myself if my negligence caused someone to be terribly affected by COVID-19. Now, you contracted COVID-19 may not terribly affect you, but if you contract it and then pass it on to someone else who may be actually killed by this virus, well, that is unacceptable to me. So knowing that, third bullet, we will do the best that we can. Remaining calm is an important aspect of this, and I know anxiety is high enough already. And my tone during this presentation may have come across as harsh or a little too serious. However, there's a reason for this. Right now, during this presentation, it's not a big deal because you're looking at it through a computer screen in a safe place in your house. Come Monday, and every day after that you may be entering into this building, into the high school building, we are putting ourselves at risk. Every single person on this planet who has not contracted COVID-19, and even some that have, may be possible vectors for disease. They can be somebody who has it that can spread it to someone else. So, knowing that, listen, we're going to get used to this class, and it will be fine. And most importantly, we will not spread the virus in this class. And final bullet here. Listen, this is not a reason never to come to school. However, for the first time in my 15, and my father used to yell at me all the time, you'll feel better. You'll feel better if you go to school and do something, when I was feeling sick. Not the case this year. And as I've gotten older, I seem to agree with him more and more, even though I couldn't stand him when I was younger. However, in this case, his old school thinking is wrong. If you don't feel good, don't come to school. And even on another level, if you lose your sense of smell, definitely don't come to school. It's one thing that is shown prominence is the loss of smell when contracting the coronavirus. Actually, Mrs. Rogalski has an acquaintance who contracted the coronavirus in March, early on. They live in Lower Westchester, so very close to us. And even to this day now, many smells actually are being transmitted to her brain as smelling like wet ash. You know, like you have an outdoor fire and it comes and rains and tamps the fire out, and then the wet, nasty, gooey cinders are giving off smoke, and it smells like wet ash. Yeah, there's that. Okay? So don't come to school if you have that. So, last thing, for Gelman, the option of logging in to the class at home is always available. I will not boot you from the Google Meet. You deserve to have the best education possible. And this is a crazy thing, and a strange thing about this is that, we can still somehow connect, and you can somehow have a literature and all of its goodness foisted upon you, even from afar. Finally, one more thing, one more video. I'm taking you out with this. I'll be wearing goggles. I am following the advice of that man on your screen right now, Dr. Anthony Fauci, one of the most, famous and most prominent infectious disease experts in the history of the world. And I don't care if you don't believe him, because I do, and I'm following Fauci.
If you really want perfect protection of your mucosal surfaces, just for your audience, Jen, as you very well know, you have mucosa in the nose, mucosa in the mouth, but you also have mucosa in the eye. And that's one of the things that, theoretically, you should protect all the mucosal surfaces. So if you have goggles or an eye shield, you should use it. It's not universally recommended, but if you really want to be complete, you should probably use it if you can.
And that concludes our presentation. Good night and good luck.